Hello and welcome to this revision session for mechanics, which is part of the revision sessions for AQA A-level physics. So in today's revision session we're going to look at answering examination questions on A-level physics and in particular the mechanics topic. So if you've been successful and learnt in this particular revision session, you should be able to answer A-level physics exam style questions, assess your understanding of A-level physics and understand what topics you need to improve upon for A-level physics. So let's look at how you should prepare for this revision session. Firstly, when completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than that of the right hand side, and in this left hand side section write down your working out and answers to the questions in the revision session. And when you're doing this, make sure you write your answers in full sentences and show your full working out. Whilst on the right hand side in this section, write down any piece of information which you find useful or any hints and tips on answering questions from this revision session. And at the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising AQA A-level physics? So the first step is learning the key facts. So use your revision guide, your class workbooks, your student prep notes, your textbook to learn the key ideas of the course. And you may wish to make mind maps or notes to do this yourself. Then second step is to test yourself. So use Caboodle, use Seneca, use knowledge checkers to quickly test your own knowledge, and you may wish to do this from your own cue cards. Then finally, step 3 is use examination preparation books, homework books, supervised study books, additional workbooks to practice examination questions and then mark your own work. And you may even wish to download your own exam pass papers to do this. So the combination of learning the key facts, then testing yourself, then practicing exam style questions is the way and how you should be revising AQA A-level physics. So let's have a look at a few questions for mechanics. The first question states, Figure 3 is an identical velocity time graph for an object oscillating about a fixed point. Determine using Figure 3 the maximum acceleration of the oscillating object. So pause the video now, then unpause the video when you want to go through your answers. Right, so how do you answer this question? Well, you've got to be aware that the gradient of a velocity time graph is the acceleration, but you've got a curve. So how can you work out the gradient of a curve? So what you would do is draw a gradient, okay, by drawing a tangent to the curve on the graph. Then you can use this gradient of the tangent to then work out your acceleration. Now again, you want to do your maximum acceleration, so you're looking at where the gradient, okay, is the highest, so where the line is at its steepest, and you should be getting between an answer of 15 to 20 meters per second. The next question says, now figure 4 is also a velocity time graph for an object oscillating about a fixed point. Determine using figure 4 the maximum displacement of the object from the fixed point. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, you've got to be aware that to work out the displacement of an object, you've got to be working out the area under the graph. But it's important to note that if it's below the graph, below the x-axis, it's going to be a negative value, and above the x-axis is going to be a positive value, because you want to work out displacement and not distance travelled. So what you would do is you would determine the area under the graph, so you can work out what each square is equal to, and then you can count the number of squares. Then you can work out your answer to be 2.3 times 10 to the minus 3 to 2.7 times 10 to the minus 3 meters. Our next question says, a tennis ball is served horizontally as shown in figure 5. The bottom of the ball is 2.75 meters above the ground and the horizontal distance of 11.9 meters from the net. The top of the net is 1.07 meters above the ground. Assume air resistance is negligible in this question. So show that the time taken for the bottom of the ball to fall to 1.07 meters above the ground is approximately 0.6 seconds, and then calculate the minimum initial horizontal velocity which the ball must have to get over the net. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, what you can do here is, because you know it's falling vertically and the only force that is acting on it is gravity, you've got a constant acceleration, so you can use suvat. So we can use suvat to show that our answer for t, so it is about 0.6 seconds. So what we can do is we can say s is equal to ut plus a half at squared. We know that a is going to be the acceleration due to gravity because it's falling downwards, so a is going to be 9.8, and then you can say we know that s, the displacement, is the difference from in the height to fall to the ground, so it's 1.07 meters. Okay, you can work out through that, so you can see that it's going to be working through from 2.75 to 1.07. You can work out your difference as the distance to fall. So you've got s, you know what your value of u is going to be. It's going to be 0 because it's starting off at is a stationary, so therefore we know u is 0, so we can say that s is equal to a half at squared. So therefore we can work it through, okay, and then you can get your answer to be 0.585 seconds. Now the next question is, well, at this point calculate the minimum horizontal velocity the ball must have to get over the net. Well, what we can say is, in the horizontal we know what our displacement is going to be. You can see in the questions 11.90. We know what our time is because you just worked it out to be 0.585. Please remember in suvat that the only quantity which can be transferred between horizontal and vertical is the time, and so therefore we can say speed is going to be equal to distance over time, so therefore, or velocity is displacement over time, so therefore we can say that the displacement, okay, is going to be 11.90. We can say that our time is 0.585, so our answer is 20.3 meters per second. Now again, it's very important to note that we can use the equation velocity is displacement over time, because in the horizontal there are no forces acting on the object, so it has a constant velocity, so we can use that particular equation. The next question says, later in the game, the ball has a horizontal component of the velocity of 42 meters per second and a downward vertical component of the velocity of 26 meters per second. Determine the resultant velocity of the ball. You may use a calculation or a scale diagram. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this particular question? Well, if you wanted to do a calculation, you should use Pythagoras. So what you can do is you know already what the horizontal component of the velocity is going to be. It tells you in the question it's 42. You know that the downward vertical is going to be 26, so we can then draw that out as a right angle triangle. So therefore we can say the horizontal component squared plus the vertical component squared is equal to the overall component squared. Work it through and then work out your answer to be 49.4 meters per second, and then you can use your appropriate trigonomic relationship by doing either sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, or tan is going to equal to opposite over adjacent to work out your angle, which is 32 degrees. The other way in which you can do that is to draw a scale diagram. So again, draw your right angle triangle to scale, so you can look at the values and scale them correctly. At that point you can then draw in your resultant force by joining up the two lines at right angles. You can then measure it with a ruler and convert back to scale and measure the value with a protractor. The next question says, Figure 8 shows a section of a suspension bridge. The bridge deck is supported by a single cable attached to a vertical tower. Figure 9 is an enlarged view of the cable and the top of the tower. The cable makes an angle of 40 degrees to the horizontal where it meets the tower. The tension T in each section of the cable is 1.2 times 10 to the 8 newtons. The weight of the cable is negligible. Calculate the magnitude of the resultant force exerted on the tower by the cable. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? So we need to calculate the magnitude of the resultant force exerted on the tower by the cable. Now you'll notice that we're going to have to then work out the component, because if we look on the question we need to be thinking about the vertical, because the tower is in the vertical of the cable, so it needs to be the vertical component of the force acting on the cable. So therefore we can do either T sine 40 or T cos 50 and work out our answer to be 1.5 times 10 to the 8 newtons. It's always very important that when you're given a force at an angle, you can work out the horizontal and vertical component of the force and work out which one is relevant, which one is useful to that situation. The next question says, for the same particular suspension bridge, the mass of the tower is 7.1 times 10 to the 6 kilograms. Calculate the magnitude of the reaction R of the ground on the base of the tower. So pause the video now, then unpause the video when you want to go through your answer. Right, so what do we know here? Well, we know that when we've got a reaction force acting upwards, we know that there must be a weight acting downwards from the tower onto the ground, okay, which is of equal size to that reaction force. So what we can say is pretty much that the magnitude of the reaction force is equal to the magnitude of the weight of the tower. So what you would then say is you say we've got our mass, which is 7.1 times 10 to the 6 kilograms, and then we convert that into the weight by doing 9.81 times by that mass, and then you can add the weight of the tower to the value from the previous question, and there's our overall value of the reaction force. Our next question says, a car of mass 1,400 kilograms starts from rest and travels along a horizontal road for 90 meters. Figure 10 shows the variation with distance of the resultant force on the car. Describe the motion of the car over the 90-meter journey and calculate the initial acceleration of the car. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's important that you can be able to understand how resultant force can link to the motion of an object. So you should be aware that the resultant force is directly proportional to the acceleration of the object. That is Newton's first and second law of motion. So what we can therefore say is on our graph, our resultant force is increasing. So therefore our acceleration is also increasing. So therefore calculate the initial acceleration of the car. Now we know that F equals ma, that's Newton's second law of motion, so therefore A is equal to F over m. So we can work out our resultant force by working out the value from the graph. We can then divide it by the mass, which is given in the question. Now do remember that we're going to be using the resultant force in kilonewtons, so convert that into newtons. So 4.4 kilonewtons will become 4,400 newtons. So you can work that through and you can get your answer out. Now again, it's important to note the initial acceleration of the car. So the initial means at the start. So in this question, the resultant force at the start is 0.2 kilonewtons. So therefore it will be 200 newtons. So you'll be doing 200 divided by 1,400 to get 0.143. Right, our next question says, for the same particular graph, show that the useful work done accelerating the car over the 90-meter journey is about 2 times 10 to the 5 joules. Then calculate the speed of the car after it has travelled 90 meters. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, you should remember that work done is equal to force times by distance. So therefore, this tells us that for a force distance graph, that our area under the line is going to equal work done, because the y-axis times by the x-axis is actually the area under the line. So the work done is the area under the graph. So what you can do is you can work out the right angle triangle. Now please remember from the question, it doesn't start at 0, it starts at 0.2. So in working out your y value, you're going to do 4.4 minus 0.2, then times by 10 to the 3 because it's in kilonewtons. We then divide it by our value of 2 because it's a half AB. So for the area of a triangle, so you divide it by 2 and then you multiply it by the height of the the distance value, which is 90. So you would do 0.2 plus 4.4. Okay, so you work it through to find your difference there, times by 10 to the 3, divided by 2, times by 90, and we get 2.07 times by 10 to the 5. Now the next question says, calculate the speed of the car after it has travelled 90 meters. Now the trick to this question is that we've just worked out the work done. Now the work done is going to be transferring energy from the previous energy store into the kinetic energy store, because it's making the car go faster. So we can say our work done is equal to kinetic energy, and kinetic energy is equal to a half mv squared. So from our value of work done, we know that that's a kinetic energy store. We've got our value of mass from the previous part of the question, so you can work out V, and that's 17.2 meters per second. Figure 4 shows a golf ball hit from a mound of height 12 meters. The initial velocity of the ball is 48 meters per second at 15 degrees to the horizontal. The golf ball takes 3 seconds to reach a position at a vertical height h above the hole. D is the horizontal distance from the point where the ball is hit to the hole. Ignore the effects of air resistance for this question. Calculate D. So pause the video now, then unpause the video when you want to go through your answer. Right, now as mentioned before, because we know in the horizontal, okay, because that's what we're going to be working out here, okay, we can just use the equation distance is equal to the velocity times by time, because in the horizontal there's no forces acting on the object, because the only force acting on this object is weight, which is in the vertical, and vertical and horizontal forces do not interact or affect each other. So therefore in this situation there's no horizontal forces acting on the object, so therefore we can just use the equation velocity is equal to displacement over time, so therefore displacement is equal to velocity times time. The only trick you've got to do for this question is that you've got to remember that you've got to be using the horizontal component of the velocity. Now in this question you're given the resultant velocity, so you've got to convert 48 meters per second at an angle of 15 degrees to a horizontal component. So it's 48 cos 15. You can work that out by drawing a right angle triangle of your information. So therefore we get 46.4 times it by our time, which is 3 seconds from the question, so it's 139 meters. Now this next question says, show that the initial vertical component of the ball is approximately 12 meters per second, and then calculate h. So pause the video now, then unpause the video when you want to go through your answer. Right, so in this particular question you've got to be aware that in the vertical there is a resultant force acting on the object, and that is weight, and it's a constant resultant force, so therefore we've got a constant acceleration acting on our object. So with a constant acceleration we can use SUVAT. So with SUVAT what we can say is as follows. We can say that we can work out our overall value of h by doing s is equal to ut plus a half at squared. But firstly in part 2 we've got to work out our initial velocity, okay, in the vertical. So in that case, whilst the horizontal was 48 cos 15, the vertical is 48 sine 15. Now it's important to note in this particular situation that work out which one is sine and which one is cos for the vertical and the horizontal. You draw a right angle triangle of the situation, and you can then use the trigonometric identities that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent to work out which particular trig identity goes with horizontal and vertical. So when you've got your vertical velocity, we can then use that in our SUVAT equation. Why using SUVAT? Because we've got constant acceleration. And remember, because it's falling down, our acceleration is going to be minus 9.81 because it's going down, so it's going against gravity. So you pop your numbers in for u, because you know it's 12.4 from the previous question, times by the time given, which is 3, plus a half, times by our acceleration, which is minus 9.81, multiplied by time squared, which is 3 squared, so our answer is minus 6.9. So when we start our answer off at 12 and it's lost 6.9, so therefore it's now at 5.1 meters. Our next question says, figure 5 shows a child on a sled sliding down a slope. The total mass of the child and the sled is 75 kilograms. She starts from rest at A and descends to a vertical height of 5.5 meters to B. Firstly, state how to calculate the work done by a force, then show that the speed of the sled at B would approximately 10 meters per second in the absence of friction. So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this particular question? Well, we've got to remember that work done is equal to the force times by the displacement, or the force times by the distance travelled in the direction that the force is acting in. Now in this next question, we're going to be, by the fact that it says there's an absence of friction, we can assume that at this point that all of the potential energy store at the start of the slope is going to convert into the kinetic energy store as the sled reaches the bottom. So we can say mgh is equal to a half mv squared. We can then cancel out our values of m on each side and say gh is equal to a half v squared. We have g, 9.81. We have h from the question, 5.5, and therefore we can work out what our value of v is going to be. So that answer is 10.4 meters per second. The next question says the actual speed of the sled at B is 5.8 meters per second. The distance AB is 17.2 meters. Calculate using energy considerations the average frictional force experienced by the sled. So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this particular question? So what you would do is you could work out your predicted kinetic energy. So what you would say is the predicted kinetic energy is a half times by mass times by the velocity squared. Now in the previous question we'd worked out what that velocity should be, which is 10.4 meters per second. So we can work it out that it's going to be 4,056 joules. We can then work out what the actual kinetic energy is by doing a half times by mass times by the actual velocity squared, which is 5.8. So we get our true kinetic energy to be 1,261. So therefore the work done due to friction must actually be the difference between the two values. So it's 4,056 minus 1,261. So that's going to be our work done due to friction. We can therefore say force is equal to work done divided by distance or displacement, because we know that work done is force times by displacement. So therefore we can divide that value by 17.2, and that works out our frictional force to be 160 or 162 newtons. Now again, it's very important to remember that we can work out the work done due to friction by working out what the kinetic energy should be and subtracting from what the kinetic energy actually is. The next question says, state the principle of moments. Then figure 1 shows a uniform beam of length 3.2 meters and a mass of 27 kilograms. The beam is placed with one end against the bottom of the wall at X. A person holds the beam at 35 degrees to the horizontal by applying a force F to the other end of the beam. F is applied at right angles to the beam. Determine F by taking moments about X. So pause the video now, then unpause the video when you want to go through your answer. So it's important that you can be able to actually talk about what the principle of moments are and how you can then determine values with them. So this first question is all about just rote knowledge. What is the principle of moments? And the principle of moments is the idea that there is no resultant moment, or that you say that the sum of all the clockwise moments equals the sum of all the anti-clockwise moments when a body is in equilibrium. Now technically when a body is in equilibrium, we know that there's no resultant moment and there's no resultant force acting on the object. So what you can say here is if you take moments about X, you know that the resultant moment is going to equal 0. So we can say that the clockwise moment equals the anti-clockwise moment. So what we can say is that force times by distance clockwise equals force times by distance anti-clockwise. So what you can then do is therefore you can work out what the moment of the weight is by doing force times by distance. Now you know that the mass is 27, so therefore you can do 27 times by 9.81 times by 3.2. But also just be aware that we're going to take our component working through as well. So we can say working through to be 2 times by cos 35 by looking at the angle, so therefore that equals 347 newton meters. So what we can therefore say is that on the other side, therefore force is equal to moment divided by the distance, because we can look at our equation working through and say moment is equal to force times by distance, so therefore force is equal to moment over distance. So therefore we've got our moment on one side, so it's got to be the moment on the other side, so therefore we say it's 347. We then divide it by 3.2 because that's the distance it is from the value of X, so therefore it's 110 or 108 newtons. Our next question says figure 2 shows a ball thrown with a velocity of 15 meters per second at an angle of 20 degrees to the horizontal. It reaches a wall 0.15 seconds after being thrown. Throughout this question, assume that air resistance is negligible and calculate the horizontal distance travelled by the ball. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, once again, horizontally, we know that there's no resultant force acting on the object in that particular plane. So we can use our equation that we can say that that we can do horizontal distance is going to be the horizontal velocity times by the time. So you know our time to be 0.15 seconds, and we can convert 15 meters per second at an angle of 20 degrees to a horizontal by doing 15 cos 20. Once again, draw out your right angle triangle showing that, and then work out which identity to use. And therefore we say 15 cos 20, which is 14.1, times by 0.15 is 2.1 meters. The next question says, so calculate the height h gained by the ball and calculate the speed at which the ball hits the wall. So pause the video now, then unpause the video when you want to go through your answer. So how do you calculate the height? Well, again, we can use suvat here because we've only got one force acting on the object, and that is gravity, so or weight, so therefore our acceleration is our acceleration due to gravity. We can work out our vertical component of the velocity because we're looking at how high it goes vertically by doing 15 sine 20. So we know that it's 5.13 meters per second. We can then find the correct suvat equation to use. S equals ut plus a half at squared. We know a is 9.1 because it's acceleration due to gravity. We're given t in the question to be 0.15, and we know what u is because we started out by saying it's 5.13 and worked it out to be 0.66 meters. Now how can you therefore work out the speed at which the ball hits the wall? Well, what you would do is you could use suvat to calculate the vertical velocity when it hits the wall. So we know what our value of u is, we know what s is, we know what t is, we know what a is. So we could say, for example, v is equal to u plus at, where u is equal to 5.13, a is equal to 9.81, and t is equal to 0.15. That's our vertical velocity, but it wants the overall velocity. Now again, it's important to note that for our horizontal velocity, because there's no resultant force acting on the object, the velocity will stay constant because the resultant force causes acceleration, so no resultant force will lead to inertia. So therefore we've got our value for the vertical velocity, our value for the horizontal. We can use Pythagoras by saying the resultant is going to be the resultant squared is equal to the vertical component squared plus the horizontal component squared. So it's going to be 3.65 squared plus 14.1 squared, all square rooted, which is 14.6 meters per second. The next question shows figure 3, which shows a sphere that falls through a distance h on the horizontal ground. The sphere hits the ground and rebounds. Figure 4 shows the variation with time of the velocity v of the sphere. So calculate the value of h. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you calculate h? Well, h is going to be the displacement, which for the velocity time graph is the area under the line. So what you need to do is take the area under the graph between the time of t and 0.57 seconds. Why 0.57 seconds? Well, that's the point at which it's going to rebound and change direction because it's going to a negative, so that allows you to work out the height. So therefore we can work it out from the graph and do it to be the answer of 1.60 meters. Right, our next question says, calculate the magnitude of the acceleration of the sphere whilst it is in contact with the ground. Then the mass of the sphere is 58 grams. Calculate the force exerted by the ground on the sphere while it is in contact with the ground. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you work out this first particular question? Well, we're trying to work out acceleration. Now, on a velocity time graph, acceleration is equal to the gradient of the line. So you've got to work out the acceleration whilst the object is bouncing. And you can tell the bounce section, because if you look on your particular graph, you can tell that it's going from 5.6 to 3.6 or minus 3.6, so you can work it through that way. That's the bounce section because that's when it's doing that almost vertical line, and then we can work out our gradient that way to get 310 or 307 meters per second squared. It then says the mass of the sphere is 58 grams. Calculate the force exerted by the ground on the sphere whilst it's in contact with the ground. Now we do know that F is equal to ma, so therefore we've got our value of A from the previous question. We know our value of mass, which is 58 grams, which is going to convert to kilograms. so we can work it through, and then we can also say that weight is equal to mass times by gravity, and we know the value of the mass again, we know a value of gravity, and we can add the two together. Now remember, why do we have to add both of them together? Well, we can do that because we've got the force exerted on the ground just to the movement, which is F equals ma, but we've also got the force exerted on the ground by the sphere due to its weight. So you've got to think of all the force acting on it when it's in contact with it. So you add the two together and you get 18.4 newtons. Our next question says, okay, here that we've got another sphere of the same radius but much less mass is dropped from the height h onto the ground. For this sphere, air is insignificant during its descent. Sketch on figure 4 a velocity time graph for this sphere and from time t equals 0 when it is dropped until it hits the ground for the first time. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, you've got to understand that the end of the new line or the curve is at a later time, because it's obviously undergone air resistance during its descent, so therefore, okay, it's not going to hit the ground as quickly. And also the gradient is going to be curving now, and not a straight line, because you've got to think of the factor of air resistance. That when air resistance is significant, the acceleration it will decrease whilst the speed is getting bigger. The change of speed is getting less, so the curve is going to decrease in gradient now, and our maximum velocity is going to be lower because some of the kinetic energy has been dissipated to the surroundings with this air resistance. So I hope you've enjoyed this particular revision session on mechanics. If you've been successful and learned in this revision session, you should be able to answer A-level physics examination style questions, assess your understanding on A-level physics, and understand what topics you need to improve upon for A-level physics. So thank you very much for watching this revision session on mechanics, which is part of the AQA A-level physics specification. Thank you very much and have a lovely day.